Exploring the Solar System Part 3, looking at how we explore the solar system with telescopes, either here on Earth or at least close to Earth. Telescopes have been with us for 400 years or thereabouts. I'll be looking briefly at the history, the first views we had of the solar system, and perhaps some of the latest views as well, and asking ourselves what's next in terms of big telescopes here on Earth. So it didn't necessarily start with Galileo, but he was one of the first to take a telescope and point it at the sky, the night sky, and realize that the solar system doesn't necessarily work the way that people had assumed up to that point. In the 400 years since Galileo, telescopes have changed a huge amount, not simply by making them out of brass rather than wood, changing from using lenses to using mirrors, because it's easier to catch a lot of light with a mirror than it is with a very big lens. And so throughout the last century or so, lots of big telescopes have come online. This is about a century or so old. The Hale telescope on the right-hand side here, that was the biggest telescope in the world when I was born. It was the biggest telescope in the world for most of my childhood. It was the biggest telescope in the world for most of my adult life, but has now been overtaken by others. The space telescopes are not necessarily bigger, but they are better in the sense that by taking a telescope and putting it above the Earth's atmosphere, you only need a relatively small mirror because you're getting away with not having the turbulent effect of the Earth's atmosphere. You're not looking at very distorted images from a great distance. You're looking at very crisp images because they're not distorted by the turbulent Earth's atmosphere. So even though the Hubble mirror is not that big, it's still arguably a better telescope. And the same is true for the James Webb Space Telescope. Again, its mirror is maybe about the same size as this world's largest telescope as of many decades ago, but it really works so well because it is not subject to the blurring effect of the Earth's atmosphere. We are still building telescopes on the Earth. Just because we have space telescopes doesn't stop us building telescopes on the Earth. And in a few years' time, this absolute monster will be coming online with a mirror diameter of about 40 meters. In other words, longer than the length of this room. Absolute huge. And you probably can't see it from where you're sitting, but these little specks in the foreground are people. It gives you an idea of the scale. So Galileo was one of the first to turn his telescope on the universe and document what it was that he saw. And one of the things he saw was that when you look at Jupiter, our eyes show us 4 stars, okay, not stars, but 4 dots of light around Jupiter. Just like the moon around the Earth, these dots appear to be going around Jupiter. Therefore, not everything goes around the Earth, as was doctrine at the time. So the idea of monitoring from night to night these little stars, these little dots, and showing that they orbit Jupiter, he was very methodical as to how he documented this night after night, and hence deduced how these moons were going around Jupiter, hence proving that objects revolve around things other than the Earth, and therefore the doctrine of the church at the time must be wrong. He also looked at Saturn to try and figure out what was going on there. His telescope wasn't the best by modern standards, so he had difficulty working out what he was looking at with Saturn. He said, I see 3 round things, the middle considerably larger than the 2 lateral ones. In other words, it looks like a planet with ears. There's something going on either side of Saturn, and you can't quite figure out what it is. That was what Galileo said in 1610, and for many years thereafter, lots of other people looked at Saturn and came up with different ideas of what it was they were looking at. Are we looking at 3 separate bodies? Are we looking at a planet with ears? And it wasn't until Huygens came along in 1659 and said, I think what we're looking at is a sphere with a ring around it, and it looks odd in different telescopes depending on how good those telescopes are. That was amazingly prescient, because if we look at a Hubble Space Telescope picture from many, many centuries later, you can see basically, yep, he was spot on. It is a sphere with a ring system, and as we saw earlier, the ring system is very wide but incredibly thin. Other misconceptions have occurred, not only with Jupiter and Saturn, but when it comes to looking at our friend Mars here. Schiaparelli looked at Mars through a telescope and made various drawings. He looked in detail at various things, and he's blown it up in his notebook here. I love this notebook because you can see different pages are pasted in with half of a postage stamp there. He didn't even want to waste an entire postage stamp by sticking this in. He cut it in half and pasted it in. So his notebook is saying, I'm seeing all of these structures on the surface of Mars, these canali, which means channels. But when one person says channels and says, I can see all of these lines on Mars, all of these channels on Mars, some people took his original statement of channels and mistranslated it as canals. And then you get people saying, well, if there's canals on Mars, canals are artificial. If there's artificial canals on Mars, which is part of an irrigation system, that means Mars is inhabited. And Percival Lowell was a champion of this idea, leading to statements such as, there can be no doubt that living beings inhabit our neighbor world. Here, Percival Lowell, recognized as the greatest authority on the subject. Well, certainly the greatest authority according to Lowell, maybe not the rest of the world, but yes. So this statement that there are canals on Mars, therefore there is intelligent life on Mars, for some people was a leap too far, but he was absolutely convinced on this. He was looking through a large telescope in Lowell Observatory in Flagstaff, Arizona. So there's an image of him looking through this telescope. It is thought that with a very large telescope and perhaps a very high magnification eyepiece, maybe he wasn't looking at real things on Mars. Maybe he was picking up the blood vessels on the back of his eye and misinterpreting them as canals on Mars. And once he thought that somebody else had seen them, he convinced himself that he could see them. Not exactly a mass hallucination, but there is this problem with there is a tendency for humans to see what they want to see, unless you are being very careful. So Schiaparelli, back in the 1800s, or the 1880s, 1890s, said, I can see very distinct straight lines. Other people said, well, I can sort of see the same structures, but I'm not convinced they're straight lines. I'm not convinced they are actually canals or even channels. And so the map of Mars changed from something that looked like the canal system to something that we now see with the Hubble Space Telescope. Lots of detail, but no real sign of any artificial canals. So that's now been relegated to history. And I hope that this looks a passing resemblance to what you see with Mars rotating in the background there. Now, amateurs now have access to telescopes which are far higher quality than Galileo had when he was making his own lenses. Amateurs now, for a few £100s, and certainly if you want to spend more than a few £100, have access to very high quality instruments, whether they are refractors that use lenses or reflectors that use mirrors for collecting the light, or some types of telescope that use a combination of the two called catadioptric, or CATS for short. And some amateurs take it to extreme. Some start with a small telescope and then get hooked and want to see more in terms of either planets in the solar system or perhaps distant galaxies in the universe, and decide that they want to upgrade from a small telescope to a much larger telescope. Well, the options are there if you want to, and if you're having difficulty judging the size of that, well, that's how big it is. It weighs a lot, but don't worry, the manufacturers have thought of that, and they've made sure that your bank balance will be considerably lighter if you decide to buy one of these things. So yes, amateurs can take it to extremes if you've got more money and you want a second mortgage on your house. And of course, the professionals are also going to larger and larger telescopes. What is the drive, apart from kudos, of going for a larger and larger telescope? It's partly the fact that a larger mirror, a larger telescope, will collect more light, and hence you can see fainter objects. But also a larger lens or a larger mirror will give you sharper images, so you'll see more. You'll see more detail as well as seeing fainter objects. So it's a double whammy for going for larger and larger apertures, which is the word we use for simply the size of a lens or mirror. These days, all big telescopes use mirrors, and this simply gives you a graphic giving you an idea of the relative sizes of telescopes over the last century or so. And if you're having difficulty with scale, there's a human there who you can hardly make out. And to make it a little bit easier, there's a basketball court, and there's a tennis court just peeking in at the bottom to give you a sense of scale. So 100 or so years ago, the sizes of telescopes, the mirror was measured in a few meters. The Hale telescope, for instance, had a mirror diameter of 5 meters, a little bit less than the Mars globe behind us at the moment. But you can see from the graphics here how they've been getting larger and larger and larger. The largest telescope in the world at the moment is the Gran Telescopio Canarias. As you can tell from the name, perhaps it's sitting on the Canary Islands. That was in operation in the noughties, and it is still the largest telescope in the world, but it will soon be overtaken. By comparison, space telescopes are in the bottom left-hand corner, and notice they are not particularly spectacularly large. We would like to have space telescopes with the largest mirror possible to see out into the universe and to see the planets a bit more clearly, but it's simply difficult to get big telescopes on the top of a rocket and get it up into space. So space telescopes tend to be on the smaller side. But you can see that there are telescopes coming along. There's a so-called very large telescope that's been in operation for a while, and coming online soon, the extremely large telescope. You can see astronomers are not good at naming things. They haven't quite decided what the next telescope beyond that will be. People are talking about this large circle in the background, and they're calling that the OWL, the OWL. Is that because owls have large eyes? No, because the OWL would be the overwhelmingly large telescope, because they're running out of adjectives. But at the moment, this one is almost ready. Another couple of years, and this telescope, with a diameter of mirror 40 meters, collecting huge amounts of light compared to these telescopes of old, and unimaginably more light than, for instance, the telescopes of Galileo. So this, as I said earlier, the Hale telescope with a 5-meter diameter mirror, a little bit less than the Mars globe here. That was the largest telescope in the world for quite a few decades, about half a century. That was the largest in the world, but it is going to be overtaken shortly. Where are all of these big telescopes that are Earth-based? We know the space ones are up there in space somewhere, but the best observatory sites in the world for telescopes tend to be volcanic islands, such as, for instance, the Hawaiian Islands in the middle of the Pacific, or La Palma and Tenerife, the Canary Islands, again volcanic. Sticking the telescopes on the top of a volcano means that as long as it's dormant and doesn't go off, you get very nice steady air and you're high in the atmosphere. The other good place to put telescopes is in the Andes. Again, very high mountains, very dry air, very little water vapor in the air, and as high as possible so that not too much air above you. If you look at the Andes, you get an idea of what it's like. This is an observatory photographed from another mountain top some distance away, and you can sort of see that you're above an awful lot of the Earth's atmosphere. A lot of cloud is below you. You have clear skies above. If you want to go higher than a mountain top, well, you can do that. You can put your telescope in a 747 if you wanted to and fly it at 10,000 meters altitude. That's what they did for a while with this. It's called SOFIA, the Stratospheric Observatory for Infrared Astronomy. There's an infrared telescope in the back there. This has been recently decommissioned, partly because the James Webb Space Telescope is an infrared telescope, so they don't really need this anymore. So watch out on eBay, because there might be a 747 coming online before too long. But of course, getting above the Earth's atmosphere is preferable, even if it means going for a smaller mirror. If you get above the Earth's atmosphere, it's not the absorption of the Earth's atmosphere, it's the turbulence of the Earth's atmosphere blurring your images. By getting above the atmosphere, you no longer have that problem. They wanted to do that with the James Webb Space Telescope, a complementary telescope to the Hubble Space Telescope. Complementary because it's working at a different color of light. It's working in the infrared part of the spectrum rather than the visible part of the spectrum. A huge mirror in terms of space telescope standards, not big by the standards of Earth-based telescopes, but big in the standards of space telescopes. So big they had to fold it up into this piece of origami before they could put it on top of a rocket and then launched it on Christmas Day 2021. So the James Webb Space Telescope has now been around for 3 years. It's doing some wonderful stuff looking out in the distant universe, looking back in time to the very early days after the Big Bang, looking to see how stars and planets are forming. And along the way, it's also been used to look at planets in our own solar system. So there's the Hubble Space Telescope image of Jupiter on the left, perhaps a familiar sight. And it looks a bit odd to see it on the right in different colors. When you're taking images in infrared, you can color it how you like, because infrared is not part of the visible spectrum. So when you use different infrared wavelengths or infrared colors to take your image, you can then color the final result how you like. And in this case, you can see, regardless of the fact that it's different colors, we are seeing different things. We're seeing different structures in the cloud systems. We're also picking up this glow at the top and the bottom. That's not an artifact. That's the northern and southern lights. It's the aurora borealis and the aurora australis on Jupiter. Jupiter has a very strong magnetic system, and so it has aurora just like the Earth does. So it's complementary in the sense we're picking up different chemical information about what the belts of Jupiter are made of, and hence what the storm systems are actually doing. If we do the same and compare a Hubble Space Telescope image of Saturn, a beautiful image, it looks lovely and crisp. We can see the bands on Saturn, not quite as distinct as Jupiter, but again it has belts and storm systems, and of course the beautiful ring system. If we have a look at what the James Webb Space Telescope sees of that, it's a similar resolution. Despite having a larger mirror, the amount of detail that James Webb can see is about the same as the amount of detail that Hubble sees. But because it's working in the infrared rather than the visible, Saturn looks rather different. It looks like the planet is very dull and the rings are really bright. And that's partly because in the infrared, the gases in Saturn, mainly hydrogen, helium, and probably some other gases in there as well, like methane, don't tend to emit much in the infrared. But the ring system is lots of tiny ice particles, and they reflect and emit infrared copiously. So in other words, the rings actually look really bright, and it looks a bit odd to see a planet where the surface of the planet is rather dull, but the rings are really bright. But that tends to be what you see when you're looking at planets which have ring systems which are made of ice particles. And that's why when you look at something like Uranus, in the visible part of the spectrum, you can hardly see the rings. But when you look in the infrared, the James Webb Space Telescope shows not only a storm system raging, that bright spot on the left-hand side of the planet, but again, the ring system shows up with exquisite detail as well as being very bright in this particular part of the infrared. The same with Neptune. Neptune shows a storm system and lots of other cloud structures and a clear ring system. The rather odd-looking object way up here, why is that so bright? Is that a star that happens to be in the same field of view? No, that's one of the moons of Neptune. It's Triton. Why is Triton so bright? It seems to be a lot brighter than the planet itself, because that particular moon appears to have nitrogen ice on the surface, and nitrogen ice reflects infrared extremely efficiently, and therefore we are seeing it very bright in the infrared wavelengths, in the infrared colors, compared to what we would see in visible light. So what's next? We have telescopes on tops of mountains, and we have a couple of telescopes. Well, actually we have more than two, but a lot of people know about the Hubble and the James Webb Space Telescope. There are other telescopes coming online fairly shortly. This one is being put together in Chile. It's either called the Large Synoptic Survey Telescope, which is so much of a mouthful, we're going to lose that at some point. It's a telescope which is capable of doing a survey of space and time, meaning it's going to survey all of the sky that it can see, and it will do that over and over and over and over again, and it will not only map everything that's out there, it also will look for things changing. For instance, objects in the solar system that we might not have catalogued yet. It will find even the faintest objects that move from night to night that must be part of perhaps the asteroid belt or even the Kuiper belt. It is likely that it will find thousands upon thousands upon thousands of new objects in the solar system that we didn't actually know existed. There's a huge camera at the front of this telescope. The mirror diameter is about 8 meters, larger than the Mars globe behind me here. And the camera at the front of this telescope, that's what it looks like to scale to a human on the right-hand side. It's a huge camera, and it's going to be surveying the sky night after night after night for the next 10 years. and it will likely find lots of interesting objects, supernova and galaxies, as well as lots of interesting objects within our own solar system. And I've already said that one of the major things that's coming online fairly shortly, perhaps 2027, perhaps 2028, put back a little bit because of COVID, like most other projects, the so-called European Extremely Large Telescope. The Americans are also building a really big telescope, but the Europeans are getting there first. 2028, perhaps, we'll have this telescope 40 meters in diameter. Again, let me point out the fact that we have a couple of people standing on that gantry and a couple of people standing out front. It is an absolute monster. This one is on the top of a mountain in Chile. There are other similar sized projects in the pipeline. And the question is, when we have a mirror that big, how much of the universe are we going to be able to explore? What are we going to find within the solar system that will blow our socks off when we start collecting that much light and seeing that much detail? So if you're interested in what the Hubble and the James Webb Space Telescopes are doing currently, or if you're interested in the new projects such as the Survey Telescope on the left or the Extremely Large Telescope on the right, if you follow those websites, you can get all sorts of information about what they have been doing, what they will be doing, and all of the images and all of the spectra that they will be or have been studying to tell us more about how the solar system works, as well as how the universe more generally works. Thank you very much for listening. Could we have the lights back up now, please? Thank you.